In this video, we're going to talk about how to solve exponential equations with common logarithms. So when we first began discussing logarithms, we said the whole purpose of logarithms was to be able to solve exponential equations like 2 to the x equals 55. In this problem, we have an unknown exponent, and so we can determine the exponent by actually going ahead and taking the common log of both sides. So that's going to give us the equation log of 2 to the x equals log of 55, and we can actually now solve this equation for x. And so that's going to require a few more steps, which is what we're going to go over in today's lesson. So what we need to do in order to solve this is remember the power property of logarithms. So this is a very important property that helps us solve these equations. It tells us basically that if we're taking the log of something that's being raised to an exponent, we can bring that exponent down in front and turn it into a coefficient. So if you have the log base b of m to the r, that r is going to come down in front, and you can see here it's going to turn into a coefficient. So we can use this to rewrite logs. So if we have the log of 5 to the x, that x is going to come down in front, and this is going to turn into x log 5. If we have the log of x cubed, that 3 is going to come down in front, and this is going to turn into 3 log x. So now we can use logs to solve exponential equations. We're going to start off by always isolating the exponential term and then take the common log of both sides of the equation. Then we'll use the power property to rewrite the expression and we'll work on solving for x. So let's revisit that example that I initially started talking about. We have 2 to the x equals 55. So here the exponential term is isolated because 2 to the x is by itself on one side of our equation. So we can go ahead and take the log of both sides. So that's going to give us log of 2 to the x equals log of 55. Well, now the power property tells us that I can take that exponent and bring it down in front. So that's going to turn into x log 2 equals log 55. So now we need to solve for x. If you think about it, the log of 2 is just a number, right? I can go over to Desmos and I can type log 2, and you can see that it's just 0.3010, etc. Okay. So actually, when I'm solving for x, remember if I have x multiplied by a number, I can go ahead and divide both sides by a number to solve for x, right? So what I can do here is I can divide both sides by the log of 2. And when I divide both sides by the log of 2, I can actually isolate x, right? Because here log of 2 and log of 2 will cancel. So that tells me that x equals the log of 55 divided by the log of 2. If a problem ever asks you for the exact value of x, this is going to be the exact value of x, okay? But normally what we'll do is we'll approximate x by typing this into our calculator. We're just going to do log 55 divided by log 2. And we're just going to go ahead and round to 4 decimal places, okay? So this is approximately equal to 5.7814, okay? And that's approximately the value of x. So now you can go ahead and pause the video and try doing this example on your own. So here we have 3 to the x equals 72. The exponential term is isolated, so I go ahead and take the log of both sides. Then I rewrite it using the power property, which gives me x log 3 equals log 72. I divide both sides by the log of 3, which tells me that x is the log of 72 over the log of 3. If I go ahead and type this into Desmos, log 72 over log 3 is approximately equal to 3.8928. So now let's look at an example that looks a little bit different. We have 5 to the 2x equals 34. Well, you see here, our exponential term is isolated, right? That 5 to the 2x is by itself, so I'm going to go ahead and take the log of both sides. So the log of 5 to the 2x equals the log of 34. So notice here my exponent is a little bit different, right? It's a variable with a coefficient. So when I bring that exponent down, I'm going to bring all of that down together. So this is now going to turn into 2x log 5 equals log 34. So now I need to isolate x. Well, what I'm going to do here is notice that x is being multiplied by two things. It's being multiplied by 2 and it's being multiplied by the log of 5. So if I just go ahead and divide all of that out in one step, so if I just divide both sides by 2 log 5, that's going to allow me to isolate x, right? I'm just getting rid of everything that x is being multiplied by. So when I do that, you see here these 2's cancel, the log 5 cancels, so I've now solved my equation for x. So I have x equals log of 34 divided by 2 log 5. Okay, so once again, I can approximate this value using Desmos. I'm just going to go ahead here and type log 34 divided by 2 log 5, and that's approximately equal to 1.0955. So now you can go ahead and pause the video and try doing this example on your own. So here I have 8 to the 3x equals 71. So I start off by taking the log of both sides. Then I use the power property to bring down that 3x. So I have 3x log 8 equals log 71. I'm going to divide by everything but x. So I'm going to divide by 3 log 8 on both sides. And then I'm going to go ahead and go to Desmos and approximate this value. So I have log 71 divided by 3 log 8. And that is approximately 0.6833. So now let's look at this example. So here we have 2 times 6 to the x equals 75. Remember, our very first step is to isolate the exponential term. Okay, so if that exponential term is not by itself, you see here the exponential term is 6 to the x. If it's not by itself, I have to do an opposite operation to isolate it. So it's being multiplied by 2, right? Remember, the opposite of multiplying by 2 is to divide both sides by 2. So I'm going to go ahead and divide both sides by 2. So when I do this, I'm going to get 6 to the x equals 75 over 2. Okay, so I'm going to leave that as a 75 over 2 because the thing with working with logarithms is you want to leave everything as it is and go to the calculator in your very last step. Okay, we'll see more of this when we get to the word problems because we're trying to avoid rounding errors. So you want to leave everything as is and then go to the calculator in your final step. So now I have my exponential term isolated, right? I have 6 to the x equals 75 over 2. So now I can take the log of both sides. So I have the log of 6 to the x equals the log of 75 over 2. And what I'm going to do now is use the power property to rewrite this. So I have x log 6 equals log of 75 over 2. And I'm just going to divide both sides now by the log of 6, right? Because I want to isolate x. And so that's going to give me x equals log of 75 over 2 over log of 6. Okay, and I can go ahead now and approximate this value using Desmos. I'm going to type log, and then I'm going to do parentheses 75 over 2, and then arrow to the right, and then close the parentheses before I do divided by log of 6. You want to be careful when you're typing and just always look at this and make sure that it looks exactly like what you've written out in your work. So we have approximately equal to 2.0228. Okay, and that is the approximate value of x. Okay, so now you can go ahead and pause the video and try doing this example on your own. So here we have 4 times 3 to the x equals 32. So I go ahead and start off by dividing both sides by 4. That gives me 3 to the x equals 8. And I go ahead and take the log of both sides, then rewrite using the power property. So I have x log 3 equals log 8. I can now divide both sides by the log of 3 to get my answer. So I have log of 8 divided by log of 3. And so x is approximately equal to 1.8928. So the common log can be used to solve exponential equations. Remember to first always isolate the exponential term before applying the common log to both sides to solve the equation.